presentation. Now we have a few questions. The first question that we have is for Brad. I hope you're still there.
Yeah, I'm still here.
Perfect. So the question is, thanks for the great talk. How are the spike neural activated? What is the input?
Right. Okay. So in the models that we tested so far, we had a combination of a background of random spikes just applied to the network, plus a fixed input pattern that was just a sequence of spikes that was generated a priori and fixed that we presented over and over to the network, sort of like you can imagine. So I come from the auditory neuroscience field, so we would present bird songs, kind of over and over to get neural responses. We're doing some more tests where we are perturbing those spike patterns and seeing how the responses in terms of the threads change as a function of those perturbations. So, but that's how the network was driven.
Great, thanks. So the next questions, I believe, is for Antonio or Daniele, whoever's one. Do you see any use for distribution that are not Gaussian, perhaps to better model long-tail distribution, for example?
Yeah, I will answer. So, yeah, in general, we assume to use a Gaussian, but in principle, we can also use other distribution to model each component. So we are not restricted to the Gaussian. We believe that the Gaussian is not a limitation because we are using a Gaussian for each domain. So it means that the distribution of a class is represented as a mixture of Gaussian. So if we have enough Gaussian, we can approximate distribution that are not Gaussian. So this is, we think that it's important to have an infinite model to represent the distribution of a class. While in other approach like the LDA, they assume a Gaussian for each class. That can be a very strong assumption.
Yeah, like the moon dataset is an example. So you cannot represent the moon with the Gaussian, but you can split the moon into several Gaussians, right? So you can model any kind of distribution.
So another question in that direction from Marty. Could you compare the use of EM algorithm, commonly used to train mixture of Gaussians, with the variational learning algorithm that you guys are proposing to the use of?
Yeah, so in the infinite case, we cannot use the expectation maximization algorithm anymore because we have this issue that we have an infinite number of mixtures, so the posterior is not tractable. So this is why usually these kind of model are trained using either variational inference or sampling methods. We believe that variational inference is more suitable for this in the continual setting, essentially because it allows also to perform online learning using the stochastic version of the variational inference. And yeah, while the sampling methods, I don't think that they cast very well in a setting where you receive data over time. I don't know if Antonio agree or if there are any questions about it.
Yeah, I don't have anything to add.
Great, thanks. Seems I don't see any more questions. We will thank the presenters. Thanks Jeremy, Brad, Antonio, Daniele for the talks. With this, we end this session of this paper session, and now I will leave you guys with James. James will be charged on the next section. Yeah, hopes you guys will still continue having fun in this marathonical 24 hours and conference. Thanks again.
Thank you very much.
Thank you.
Thanks.